Hi, my name is Rocco, and in this video I will talk a bit about the project that I've done for the Google's Generative AI Intensive course. As you can see, the title of this presentation is Building an AI Agent for Research Assistants. So let's start with an introduction to the project. First off, what was this project about? This project was about building an AI research agent that should be able to help the user find relevant articles about their research topic. The user should also be able to choose an article to have a retrieval augmented generation based question answering about. Why did I choose this topic and what problem does this project aim to solve? I chose this topic because I remember how hard it was to write my master's thesis a few years ago. Only a fraction of papers that I looked at actually matched the topic. I spent days and days trying to find relevant methods. Now, a few years later, with thousands of new articles each day, I can only imagine how hard it is to find relevant papers and keep up to date with all the news. Which lessons can we learn from this project? This project was created using ChromaDB, Google's generative AI, and LangChain. The code covers all the implementation steps, such as generating and storing embeddings, using retrieval augmented generation, and building an AI agent. In this video, though, I will only give a high-level idea of the project and the thinking steps that led to the solution. If you are interested, related code and blog post will both be linked in the description of this video. Let's go into the project overview. We will use an amazing dataset on Kaggle called the arXiv dataset. The dataset contains titles, abstracts, and metadata for all the papers on arXiv. Also, the great thing is that it is updated regularly. We want to build the agent with the following functionalities. First off, the agent should be able to provide user with relevant articles upon request. In order for that to work, we will first have to embed the titles and abstracts of the papers and store the embeddings into a Chroma database collection. The agent should also be able to retrieve desired PDF files from arXiv, embed those chunk by chunk, and provide a question and answering session about them. So we will actually have two collections of embeddings in our project. First one that will be used for storing the arXiv metadata, and another one that will be used for storing complete PDF files. Now, let's go over a quick example of what the conversation between the agent and the user should look like. First off, the agent should say, Hi, how can I help you? Maybe it should describe also what its capabilities are. The user should say, Hi, I want to learn about topic X. Agent queries the database for relevant papers. Agent then returns relevant papers to the user. Here are the top papers I found related to topic X. User says, I'd like to dive deeper into paper Y. Agent prepares for the discussion by downloading the paper Y and storing it chunk by chunk into the PDF database. Agent says, Article Y is ready. Let's talk about it. User and agent can then have a detailed conversation about the paper. User notifies agent that he is done with the paper. Agent then removes previous paper from the database and prepares for the next one. User can then choose whether to go on to another topic or exit the conversation. User should also be able to exit the conversation at any time. What differentiates an agent from a regular LLM are the tools that it can use. For our use case, we will create 4 of them. First one will give our agent the ability to search the arXiv database for relevant articles. It should be used by the agent after the user provides a research topic. Second one will give the agent the ability to download the desired article and embed it into the PDF database. It should be used by the agent after the user selects a paper they want to talk about. Third one will be used by the agent to search through the paper in order to find answers for the user. Finally, fourth one will be used by the agent to clean up the PDF database in order to prepare for the next paper. Here is an image of the execution flow of our interaction with the agent. The core of the interaction is the loop between the user and the agent. After the user prompts the agent, it does not need to immediately respond to the user. Instead, it can execute any of the 4 tools that we discussed on the previous slide. Here, tools are split into 2 groups, state tools and auto tools. The state tools are the ones that can modify the agent's state and auto tools are the ones that do not need to modify the state. More about that can be read in the blog or in the code documentation. Hopefully now you understand the core idea of my project. I will stop here and for the end provide an example of the conversation with the agent. In the following 2 slides, the agent uses 3 of the 4 described tools. Try to find yourself which tools are called and when. The user messages start with user and agent messages start with model. The conversation starts with the agent explaining its capabilities to the user. User then asks the agent to search the topic of diffusion. Agent lists 5 diffusion articles. User then requests the agent to have a Q&A about the first article. Here, the user asks a question to the agent, and after getting an answer, the user says thank you and ends the conversation. Thank you for watching. If you are interested in the topic and details of the implementation, check out the blog post and the Kaggle notebook. You can find both linked in the description below. Thank you to Google and Kaggle for organizing the Generative AI course. Have a nice day.